Hi friends, see today we'll be starting our next chapter, that is mechanical properties of solids. So mechanical properties of solids, this is also called as elasticity. ఈ చాప్టర్ పేరు elasticity అని కూడా చెప్పొచ్చు, or you can call it as mechanical properties of solids. So in this chapter we'll be dealing about what is stress, strain, different types of stresses and different types of strains. So let us in the beginning we'll be studying about what is stress. To begin with, what is stress? Stress ante enti mundu chudam, okay na? So for example, you take a iron rod, you know all metallic rods behaves stress and strain, all metals under the external force or heat. When it is given, it is subjected to stress and strain. Now what is stress? For example, this is the force acting on a iron rod. For example, the length is L. Now when this force is applied on this iron rod, stress generally it is given by sigma, restoring force per unit area. What is stress? Stress ante it is restoring force. Okay, why restoring force? Because after removing that force, it may regain its original shape and size. Okay, force remove చేసిన తర్వాత మళ్ళీ వెనక్కి వచ్చేస్తుంది కొంత భాగం వరకు. Okay, that is called as elastic nature. What is elastic nature? If some external force is removed from any body, if that body regains its original shape, size and volume, that is called as elastic nature. If it is not regaining its original shape, size and volume, it is inelastic. గదవుతుందా? ఎలాస్టిక్ అంటే ఏంటి? ఎక్స్టర్నల్ ఫోర్స్ ఒక బాడీ మీద అప్లై చేసిన తర్వాత వెన్ యూ రిమూవ్ దట్ ఫోర్స్, ఇఫ్ ఇట్ ఈస్ రీగైనింగ్ ఇట్స్ ఒరిజినల్ షేప్, సైజ్ అండ్ వాల్యూమ్. ఓకే, ఫర్ ఎగ్జాంపుల్ యూ కెన్ టేక్ any elastic bodies like elastic rubber. When you apply the external force and remove, it is occupying again its original shape, size and volume. Okay, so you can take rubber as an example, and also steel also you can take an example. Steel is also elastic in nature. Okay, right. And what is inelastic? Inelastic and enti? Inelastic and after removing the external force, if it is not regaining its original shape, size and volume, it is called as inelastic. దానికి ఎగ్జాంపుల్స్ ఏంటి? ఫర్ ఎగ్జాంపుల్ బబుల్ గమ్, chewing gum. What happens when you apply the force, remove, it won't regain. Okay, in the same way clay mud. Okay, or third one, flour అంటే మీకు తెలుగులో you can call it pindi, maida pindi లేదా గోధుమ పిండి. So with that also you can take the example for inelastic, because after removing the force it won't regain, it will remain like that. Okay, like example bubble gum, chewing gum, clay mud, flour, pindi, all these comes under inelastic materials. Okay, or you can also take another example. Yes, already I have given a clay is the best example. Okay, so this is meant by elastic and inelastic, definition and examples. Coming back to stress, what I told you, it is restoring force. What are the units? Newton per meter square or pascals. So what are the units for that one? Restoring force acting per unit area, newtons per meter square or pascals. Either you can call it as pascals or newton per meter square. Now in this stress again we have three types of stresses. In stress we have three types. ఏమిటంటే longitudinal stress. Okay, in this longitudinal, okay, tensile and compressive, that later on I will be telling. Next one is shearing stress or tangential stress. And last one is bulk stress, okay, or volumetric stress. So stress lo enni rakalu unnai? We have three types of stresses. Longitudinal stress lo again tensile and compressive. Okay, shearing stress or tangential stress. Last one is bulk stress or volumetric stress. Now detailedly we will be studying about all these stresses. First of all, let us go to longitudinal stress. Units are same, newtons per meter square or dyne per cm square. Okay. Now come back to this figure now. ఈ ఫిగర్ ఒకసారి అబ్జర్వ్ చేయండి. Now what is longitudinal stress? Longitudinal stress లో ఇప్పుడు చెప్పాను కదా మీకు two types. See, longitudinal stress, in longitudinal stress we have two types. One is tensile, another is compressive. Tensile, increasing the length, compressive, reducing the length. So suppose if you apply external force here, what happened? The iron rod may increase its length. The iron rod may increase its length. If original length is L, if delta L is increased, then L plus delta L is the new length. This is called as tensile force. I mean, due to application of tensile force, the length is increasing. Length is increasing. Okay? So this is called as longitudinal stress. But compressive stress and for same iron rod, if the force is applied in this fashion, the force is applied in this way, like this. So what happened? The length is decreasing. So the length may decrease by delta L. If L is original length, delta L is the decreasing length. And L minus delta L is the new length. So in longitudinal stress, you are having two types: tensile stress, compressive stress. Clear? And units are same, Newton per meter square, because stress is restoring force per unit area. Now coming to the next one, shearing stress or tangential stress. Let us see what is meant by shearing stress and tangential stress. Okay na? Second types of stress. Second type, shearing or tangential stress. ఏంటిది shearing and tangential? Let us give some example. For example, this is a rectangle. This is a square. Now in this rectangle, if I apply some force, horizontal force, here also if I apply same force, horizontal. Suppose now the rectangle is converted into, see what is happening now? A, B, C, D. Due to this force, suppose D has come to D dash and C has come to C dash. Now see, the figure has changed, you can see. Initially it was ABCD, a rectangle. Now it has converted into AB, D dash, C dash, a parallelogram. అర్థమైందా? ముందు ఇది ఒక రెక్టాంగిల్. Because of application of horizontal force, shearing stress or tangential stress, it has converted. That means base is remaining constant, only upper part is bending. Base remains constant, only upper part is bending. అదవుతుందా? So this type of stress, okay, this type of stress, restoring force is common. This type of stress, that is force acting per unit area, is called as shearing stress or tangential stress. Keeping the base constant, only the upper part is sheared. That means rectangle is converted into a parallelogram, and here you can see square, A, B, C, D square. Okay, it is converted into C dash and here D dash. ఏమైంది చూడండి, it is converted into rhombus. You can see like a diamond ఆకారంలో వచ్చింది. అంటే now square ABCD square, initially it is square. Due to the application of the force, it has converted into what? Rhombus. What is that one? A, B, C dash, D dash. So this type of stress is called as shearing stress or tangential stress. Keeping the base of the object constant, upper part is bent or it is deviated or it is sheared. That is called as shearing stress or tangential stress. Clear? Units are same for all stresses. Newton per meter, because force acting per unit area, restoring force. Newton per meter square or dyne per cm square, centimeter square, CGS. Now let us go to the next type, that is, first one is longitudinal. In longitudinal, compressive and tensile we have learned. Now second one is shearing stress or tangential stress we have learned. Now let us go to the third type of stress, that is bulk stress or volumetric stress. ఏమిటది మూడోది? Bulk stress or volumetric stress. Okay. Now let us see the third part, bulk stress or volumetric stress. ఏంటి బల్క్ స్ట్రెస్ చూడండి ఒకసారి. బల్క్ స్ట్రెస్ ఆర్ వాల్యూమెట్రిక్ స్ట్రెస్ అంటే, ఫర్ ఎగ్జాంపుల్ యూ టేక్ an object, a rubber ball. Suppose uniform pressure delta P is applied on a rubber ball and it is compressed. So what is happening here? Volume will decrease. Volume అయిపోతుంది, తగ్గిపోతుంది, decrease అయిపోతుంది. That means when you apply the pressure, what is happening? Volume is decreasing. Okay? Due to the application of the external force or pressure on this rubber ball, volume, see dV by V. V is original volume, delta V is change in volume. The negative sign indicates the decrease in volume. Negative sign is nothing but decrease in the volume. So bulk stress or volumetric stress and enti, it is also because for this you know units. Change in volume version volume units undavu, only for this one. Okay. So again same units. What is pressure? Force by air, that is Newton per meter square or pascals. That means when you apply the force, uniform force on any body, the volume is decreasing. Such a type of stress is called as bulk stress or volumetric, and volume తగ్గిపోతుంది. Clear? So these are different types of stresses with examples. Now let us go to the next item, that is strain. Strain ante enti? So in general we will be knowing what is strain. Sometimes we will be saying strain. That is a different meaning in medical, strain. But according to physics, strain, what is strain? According to physics, what is strain? It is the deformation produced per unit dimension of a body. Definition enti? It is the deformation produced per unit dimension of the body. Per unit dimension of the body. Okay. For example, if you take any iron rod, when you apply some force, so it is changing. So here, for example, the change in length, say delta L, L be the original length. Now strain can be defined as strain, change in length by original length. What is strain here? Definition: change in length was a deformation produced per unit dimension of the body. So ఇక్కడ mathematical formula ఏంటి? Change in length by original length. So what are the units? No units. Length కొట్టుకుపోతాయి, no units. So that is when examination, if they ask you in MSET or NEET or IP, what are the units? It doesn't have any units and dimension because change in length by original length. No units. No units and dimensions. Okay. Again, strain, you are having three types of strain, just like stress. Okay. Strain, again you are having three types of strains. Enti malli same, longitudinal. Okay. So strain is again three types. Longitudinal strain. Again it may be tensile, compressive. Strain ante enti increase ana avachchu, taggina taggipochu. Okay na? So again longitudinal strain. Again shearing strain, shearing or tangential. And last one is bulk strain or volumetric strain. Same like stresses, we have again three types: longitudinal strain, shearing or tangential strain, bulk strain. So longitudinal strain and enti same, increase or decrease in length. It may be tensile or compressive. Length పెరగొచ్చు, length తగ్గొచ్చు. So delta L, this is original length. So what is strain? So change in length by original length. This is strain. This is strain. So in some books we are saying strain, they are putting as E. So better not to follow, because so many authors are coming. Somebody is telling for strain E, somebody is telling as epsilon. So better don't write any letter. You better write strain only. Okay? Because bold in the operations చేస్తారు ఈ అంటున్నారు కొంతమంది epsilon అంటున్నారు కొంతమంది దీన్ని they are writing something like this also. So better not to write any letter, write the spelling only strain. Okay na? So strain ante change in length by original length, maybe tensile or compressive. Change in length by original length. Now coming to shearing or tangential strain. Adenti, for example, see here. Again, take the rectangle. Now I will take a solid rectangle. Coming to second part of strain. This is a solid rectangle. A, B, C, D, E, F, G, H. For example, here an horizontal force is applied. Now what happens to this one? See here. When force is applied on the solid rectangle, see what type of strain is going on here. Just చూడండి ఒకసారి. So then base remains constant, only upper part is changing. So here A, B, C, D, E, F, G, H. So here, see here, C is coming to C dash, G is coming to G dash, and D coming to D dash, H coming to H dash. See how much strain is there in this body? Base is constant, only upper part is sheared. That means some displacement is gone. For example, say this is some x or delta x. Okay? So from this, let this angle be theta. That is why shearing strain or tangential strain is also taken as tan theta. Is also taken as tan theta. Opposite by adjacent. Delta x, for example, this is length L. Opposite by adjacent, delta x by L. So sometimes shearing strain is also indicated as tan theta. Okay? Delta x, see, you can see. Solid rectangle is converted into parallelopiped. Little bent it is. You can see. Solid rectangle is converted into parallelopiped. Upper part is sheared, base is constant. Okay? So sometimes it is written as tan theta, delta x by or dx by L. Delta x and dx. That is opposite by adjacent. If this is theta. Okay? So that is called as shearing strain or tangential strain. Sometimes it is expressed as tan theta. Change in length by original. Only units ఉండవు. Strain ekkada kuda units ఉండవండి. Only for stress you are having newtons per meter square. Clear? Now let us go to the last one, bulk strain. Let us see what is meant by bulk strain. Now in this series, the last item is bulk strain. Bulk strain and in already I told you about bulk stress or volumetric stress. In the same way, bulk strain and enti or volumetric strain, I already told you, when a rubber ball is applied uniform force, when a rubber ball is applied a uniform force, delta P, pressure, so what you are getting? The volume is decreasing. Volume ఏమవుతుంది తగ్గిపోతుంది, decreasing. So when you are applying force, there is change in volume. Change in volume minus delta V is original volume, delta V change in volume. So change in volume to that of its original volume due to the application of external force is called as bulk strain or volumetric strain. Bulk strain or volumetric strain. ఇక్కడ కూడా మీరు అబ్జర్వ్ చేయండి, వాల్యూమ్ చేంజ్ అవుతుంది. ఒరిజినల్ వాల్యూమ్ చేంజ్ బై ఒరిజినల్ అంటే ఏమవుతుంది, వాల్యూమ్ బై వాల్యూమ్, అగైన్ నో యూనిట్స్. ఓకే, సో ఫర్ బల్క్ స్ట్రెయిన్ ఆర్ వాల్యూమెట్రిక్ స్ట్రెయిన్ ఆల్సో యూ డోంట్ హ్యావ్ ఎనీ యూనిట్స్. ఓకే, రైట్. Now let us go to the next one. Hooke's law. Let us see what is meant by Hooke's law. Hooke's law. In intermediate IPE, these questions are regularly coming for 2 marks. Robert Hooke, scientist, has given the law, this one. So according to Hooke's law, what is saying is longitudinal stress is directly proportional to longitudinal strain within the elastic limits. Within the elastic limits. Within the elastic limits, stress is proportional to strain. లేదా longitudinal stress is proportional to longitudinal strain. Okay? Or stress by strain. దీన్నే stress by strain. That is longitudinal stress by longitudinal strain is equal to constant. This constant is again called as y, and this y is called as constant and is also named after scientist Young. Okay? Therefore, it is called a Young's modulus. Clear? So, according to Robert Hooke, longitudinal stress is directly proportional to longitudinal strain within the elastic limits of any material, given material. లేదా stress by strain is equal to constant, and that constant is nothing but y. In some books also, y is also written as e. Both are right. In some books, in higher classes, y is also taken as e, Young's modulus. That is also right. But in intermediate standard, you better write y only, Young's modulus. So, this, because we have some stress by strain, you have units for y here. What is stress? Force by area. And what is strain? Change in length by original length. This is mathematical formula for Young's modulus. F by A by delta L by A, or this is also written as FL by A delta L. When you change numerator and denominator, L పైకి ఇది కిందకు వచ్చేస్తుంది, FL by A delta L. This is also another form of Young's modulus. FL by A delta L is equal to Y. ఇక్కడ చూడండి, L delta L no units కాబట్టి again force by area, Newton per meter square or pascals. So again for Young's modulus, the SI unit or MK should be again taken as Newton per meter square or pascals. So this is how you will be explaining Hooke's law and thereby Young's modulus and also mathematical formula. These are very, very important in solving numericals in IP as well as MSET examinations. Okay? Now, let us go still further in this chapter. After learning about Hooke's law, let us see some more elastic constant. After learning about Hooke's law, let us learn about some more elastic constants. Some more elastic constants. Till now we already learned about what? Young's modulus y. Okay? Young's modulus y. Now let us see what is k. See, sometimes k is also written as b in some books. This k is called as bulk modulus. Bulk modulus of elasticity. ఏమంటారు? This y is Young's modulus. K or B is called as bulk modulus. ఏంటి bulk modulus? Bulk stress to bulk strain. Bulk stress to bulk strain. Or bulk stress ఇంకో పేరు ఏంటి? Volumetric stress. Bulk అన్న volumetric stress. అలాగే bulk strain ఇంకో మాట ఏంటి? Volumetric. Bulk stress or volumetric. So the definition of bulk modulus is bulk stress by bulk strain. So bulk stress delta P, bulk strain change in volume. So again volume gets cancelled, no units. So for delta P have again units as Newton per meter square or simply pascals. So this is another elastic constant K or B. Okay. One more thing is there, eta. One more is there, that is eta. This is called as shear modulus. This is called as shear modulus or rigidity or torsion modulus. మూడు పేర్లు దీనికి. This eta is also called as shear modulus, rigidity modulus or torsion modulus or modulus. Okay, దిస్ ఈజ్ ఆల్సో అనదర్ కాన్స్టెంట్, ఎలాస్టిక్ కాన్స్టెంట్. మొత్తం మనకి జనరల్గా కాన్స్టెంట్స్ యంగ్స్ మాడ్యులస్ ఉంది, బల్క్ మాడ్యులస్, బల్క్ స్ట్రెస్, బల్క్ స్ట్రెయిన్, అలాగే లాస్ట్ది షియర్ మాడ్యులస్ లేదా రిజిడిటీ మాడ్యులస్ లేదా టార్షన్ మాడ్యులస్. ఇదైనా డిఫైన్ చేయొచ్చు. ఈటా షీరింగ్ స్ట్రెస్ ఆర్ tangential stress to that of shearing strain. How will define shear modulus, rigidity modulus, shearing stress to that of shearing strain. Shearing stress and enti normally F by A stress. Shearing strain indaka cheppanu meeku, it is nothing but tan theta delta L by L లేదా delta X by L. So this is nothing but F by A tan theta. Tan theta means opposite by this and change in length, original length, no units, only will be having for F by A. That is nothing but Newton per meter square or simply Pascals. మీకు చెప్పాను కదా, స్ట్రెస్ కానీ కాన్స్టెంట్స్ వచ్చినప్పుడు all will have same units, Newton per meter square or Pascals. Clear? So these are the elastic constants in elasticity or mechanical properties of solids. Now, after learning about this, let us go to the very important one. Around, I think sometimes he is asking for 4 marks also, and he may be asking for 8 marks also. That means 6 plus 2, one problem and also 6 marks explanation. Okay, we'll go to that one now. Very important. That is behavior of the wire under gradual increase of load. Very important question in the IPE. Behavior of the wire under gradual increase of load. Behavior of the wire under gradual increase of load. See, before going to that one, we have one more formula also. Suppose if density also given, suppose if density is given, rho, bulk modulus B or K is given, okay, density and bulk modulus, and if pressure is given, delta P. We have a relation for this one, please note down. Rho dash is equal to rho into 1 plus delta P by B. B or K, anything you can use. B is for bulk modulus. Bulk modulus ki B అని వాడొచ్చు, you can also use K. This formula is used in numericals. Rho dash, new density, rho, initial density, delta P, pressure, that is force by area, B, bulk modulus, B or K. Okay, bulk modulus చెప్పాను కదా, bulk stress to bulk strain. This formula you can use for numericals. Rho dash is equal to rho into 1 plus delta P by B. Okay, very important formula. Now let us study about the behavior of the wire. Behavior of the wire under gradual increase of load. Okay, see here I am drawing graph also for this one. X axis, y axis, okay, and x axis I will take strain values, and y axis I will take stress. Okay, stress F by A. So for example, if you take any material wire, on that if you add gradually some load, okay, and also after adding gradually load, note down the readings, how much extension it is done and how much stress is there. Again remove the loads. So దానికి మనకు స్ట్రెస్ స్ట్రెయిన్ కొన్ని వాల్యూస్ వస్తాయి. స్ట్రెయిన్ వాల్యూస్ అన్ని x యాక్సిస్ మీద, స్ట్రెస్ వాల్యూస్ అన్ని y యాక్సిస్ మీద తీసుకొని, ఇఫ్ యూ డ్రా ఏ గ్రాఫ్, this is the origin, let this be A, let this be A. If you observe the graph, see, first it is a straight line, next small curvature B, C, and next D, E, F. See, this is the graph for behavior of the wire under gradual